Welcome back to a new episode of Code Savvy. TOON stands for Token Oriented Object Notification, which is what we'll be seeing today. Now, what is TOON used for? So, TOON is essentially used for serializing JSON data that's used in LLM prompts uh, into a more compact and human readable format. Now, compared to JSON, which is what is being used currently in LLM prompts, TOON is claimed to be much more faster, more efficient, more accurate, and by all of this, it implies it's more economical in terms of the number of tokens it uses. Or is it? Let's find out. So I am on the page github.com/toon hyphen format slash toon. So this is the official GitHub repo for TOON. And let's see what it says here about TOON. So it says it's a compact, human-readable, schema-aware serialization for LLM prompts. And the workflow it's shown as it takes the JSON data, it encodes it into TOON, and it sends into LLM. And what it claims is that the tokens, the number of tokens that's taken as compared to JSON is around 30 to 60% less. If we scroll down a little bit more, it gives a few examples on why we should be using tool. And what it says is that it's giving some examples whereby it says that for this sort of data, JSON data that's being sent into the LLM, YAML conveys the same information with fewer tokens. So the number of tokens is essentially less. And if you look into tool, it will be even less than YAML. Now, before we actually delve more into the details here, it's essential to understand what is meant by a token. So token, you can think of a token as being a unit of data that's being processed by the LLM. And there are different methods or different formats by which LLMs try to measure these tokens. And a general rule of the thumb is that for the English language, it's 3 or 4 characters that's considered as a token. Now, this can include comma, spaces, brackets. So bear in mind all of this constitute a token. And when you send in a prompt into a LLM, right, you have to be mindful of the number of tokens it consumes because you will be charged based on the number of tokens you input and the number of tokens the LLM outputs for you. So something we have to be very careful about. And if you think about what is being claimed here, that if you use toons, you will find around 30 to 60% less tokens being generated. You must think in terms of millions of tokens being generated by you in JSON. And when you translate it into savings by using toons, the savings is quite huge. Okay. So that is something you really have to bear in mind. The page then goes on to show some benchmarks regarding the accuracy and the number of tokens taken. So it gives some interesting comparisons. Okay. So it says that, for example, here it says for TOON, the accuracy of the tokens is around 73.9%, which is higher than JSON compact, higher than YAML, higher than JSON. And the number of tokens it generates is quite less than JSON compact, YAML, or JSON or XML, as you can see. Then it grows, it then further compares the accuracy among 4 LLMs on 209 data retrieval questions. Essentially, the whole idea here is to showcase how this is more economical, more efficient, more accurate. The page then goes on to list some key features which you can go through at your own convenience, but essentially it's a rehash of what I have just mentioned there. What I would but like to focus on more is when not to use tool. Okay. And this is something I think people miss a lot. So is this something that you can always use and will always give you the best results? The answer is No, it won't always give you the best results. And this is very explicitly mentioned in this page, that when you should not be using tools. For example, you should not be using it for deeply nested or non-uniform structures, or semi-uniform arrays, or pure tabular data. So for example, here it says that CSV is smaller than TOON for flat tables, and TOON adds minimal overhead. So essentially, it increases the overhead if you are using CSV data. And if you're using something, if you want to use TOON for something like latency critical applications, it's recommended you do not do that. It's not suitable for that. And so we will be looking into a use case whereby the number of tokens generated by TOON is actually more compared to a JSON. So let's get into some real world cases, and I'll just run a couple of programs to show you the number of tokens that's being generated versus by a JSON versus two. Let's look into that. So let us first look into a very simple script, a Python script, which tries to showcase how much more efficient and economical Toon is over JSON. So I have here a very simple JSON data being hard coded, which I'll be sending into the LLM model here. And essentially, it says it has a couple of entries, three entries actually. It has name, email, and an array called posts, which has a couple of indexes there. So you have title and content there. And I have the JSON string, and I'll be converting it into a Toon string. So this is the Toon string that's being used. And essentially, right away, you can see that the number of characters is obviously less than the number of characters that's being used in the JSON string there, right? But the representations is the same. So it's absolutely the same. What it tries to convey is absolutely the same. So I'm using for encoding the model, I'm using GPT 3.5 Turbo, and for a fallback, I'm using CL100K slash base in case the first model doesn't work. It will work, don't worry. Okay. And I'm encoding the JSON tokens, I'm encoding the TOON tokens, and essentially I'm doing a comparison where I'll be printing the statistics of what is more efficient than, or which is more efficient than which, okay? And it will print the percentages and all. So let's run this program. So let me increase the screen state, the terminal state, and the command is just, I'll just run Python space, the program name .py, okay. And right away we have the results there. So you can see that the JSON token count is 81, and the TOON token count is 61. And essentially JSON uses 20 more tokens than TOON. Uh, so there is a saving of around 32.79%, which is well within the range which we saw in the official GitHub repo for TOON, right? So if you remember, it mentioned a savings of around 30 to 60%. So this is around 33%. Now let's look into another example. So this is a separate or another program or script that I have, which uses a much more complex sort of data structure, right? So it is a deeply nested configuration object. And though the official page says that for deeply nested structures, uh, there is a chance that JSON might be more efficient than TOON. But in this particular case, or in this particular example that I have used, uh, it was the other way around. So TOON is more efficient here. So I mean, the logic is absolutely the same that I've used before. I'm just using a nested configuration for JSON here. I'm converting that into TOON, and the other things remain the same. I'm using the encoding model GPT 3.5 Turbo, and I'm just printing the statistics there. So let me try running this and show you what I mean. Okay. So this is, yeah. So this is compared to, let me run that. And let us look at the results. So if you look at the results, the JSON token count is 115, TOON is 101. Okay, and JSON uses 14 more tokens than TOON, so there is a saving of around 13.86%. So it's not the case that TOON was more efficient, but if you see the difference between the first use case we saw and this use case is significant. So in the first use case, we had a saving of around 33%, whereas here the savings are only around 13.86%. And this is essentially what the official page for TOON is trying to say, that the more nested the structure is, the chances that your savings uh, will be greater is less. Okay, so it has an impact on your savings. So if your structure is super nested and it is super complicated, maybe it makes sense to stick with JSON and just don't go for the overhead of using TOON, because the cost savings might be negligible. Now finally, let us look into an example whereby the savings for JSON is higher. Okay. So let's go into that example. And this is the example whereby when I run it, you'll see that the actual savings for JSON is higher. Okay, so JSON is more efficient than TOON in this particular use case. And the data we are having is a very simple list of strings. Okay, you can see it, it's alpha, beta, gamma, delta, so on. Very, very simple flat list that we are having. And the problem of using TOON for a very simple flat list is that it makes it more verbose. So actually the number of tokens will be higher if you are using something like a very simple flat list here. So let's run this. I mean, the logic is the same for all the programs. So let me run this and show you what I mean. Okay. So we are on comparator bad use. Okay. So I will run this and we have the results. So the JSON token count for the simple list is 33, and for TOON it is 54. So essentially TOON used 21 more tokens than JSON, and this is a 63.64% increase, which is exponential, right, over JSON. And it absolutely does not make any sense that you use TOON over JSON for data structures such as this, because if you do that, you will see your costs skyrocketing instead of actually coming down. So that's it. I think these were the three demos that I did for you, just to showcase the difference between TOON and JSON. Hopefully that answers the question of whether TOON is always better than JSON. So the answer is no, it's not always better. So it depends upon your actual use case. And what I would strongly recommend you do is that whenever you try to do something like this, especially if you are working in an IT organization, is to do your homework, understand what your particular data structure looks like, do some POCs to understand whether there will be any savings. Because remember, Toon is an added overhead to what you're trying to do, because you already have your data in JSON format and you're trying to encode it into Toon. So there is an additional overhead there. Only do this if it really brings you some savings. Okay, so always do a POC there. And with that, we are at the end of this particular session. Hope you guys really enjoyed it. This was a short one, mercifully so. So till we see again, adios.